Newton's first law. So there's 3 parts to Newton's first law, and you need to know all 3. So I'll do them in color coordinatedness so that you can keep them apart. So the first part is objects at rest stay at rest. Okay. The second part is objects in motion stay in motion. And the third part is unless acted on by a non-zero net force. You've frequently heard this called the law of inertia. So this idea that objects resist change unless forced to change. So if an object's at rest, it will stay at rest unless you make it move. If it's moving, it'll remain moving at a constant speed unless you make it speed up or slow down. Okay? That's this idea of inertia. Objects that have more mass have more inertia, therefore they're harder to change. A fun question, well, let me ask you this one, then I'll just ask a fun one. So standing on the aisle in an airplane, you decide to jump into the air. Relative to your starting position on the floor, where will you land? You have 3 options. You're going to land in front of where you were, behind where you were, or exactly where you were. So on the airplane, you jump up. If you put an X under your feet, where will you land? In front of the X, behind the X, or right on the X? Again, take 10 seconds and think of your answer. Okay. How many people think you will land ahead of where you jumped? Excellent. That's the wrong answer. Good job. Okay. How many think you will land exactly where you jumped? And how many people think you'll land behind where you jumped? Oh, good. It's about what it normally is. You will land exactly where you jumped. You will land in your same spot. Why? Why will I land exactly where I jumped from? Maxim.
Because you're already going forward with the plane. Because it's going forward.
Yeah. The airplane's going forward. That means you're going forward. So if you jump up, you're going to move forward at the same pace as the plane. You'll land where you were. Okay? So inertia carries you forward. Now, that's a little bit of a funky way to say it. Technically, there's nothing making you go forward. Inertia is not a force. Inertia doesn't make you do anything. It just is the reason why you keep doing it. But inertia carries you forward. Okay, but I don't see the plane from where I am. I'm like in the plane. I don't see it, though. So when I jump, I'm at rest. So if the airplane's moving forward and I'm at rest when I jump, why don't I go backwards? Because if I'm at rest, and therefore the airplane's at rest, when I jump up, nothing would make me go back. I would land where I was. Like, being on an airplane is just like being here. Except to our perspective, the airplane, we know the airplane's moving, right? So like we think, well, it would move out from under me. Well, guess what? When I jump up, the room's not at rest. Right?
Yeah.
The Earth's rotating. So if the thing happened on the airplane where I jumped up and the airplane moved out from under me, that would happen here if I jumped up because the Earth's rotating so fast. And so we are moving with the Earth. The same thing's happening with airplanes, right? When the airplane's going, like the Earth's not moving out from under the airplane. Like the airplane is the air and everything with the Earth is rotating too. Now that does make some weird stuff happen. That's why storms usually come from the west. Something called the Coriolis storms. Anyway, that's neither here nor there. Here's another fun one. Do you think it's easier to throw a bowling ball on Earth or in space? Or is it the same? Space? Okay, space. Anyone think it easier on Earth? Good, that's not the answer. Anyone think it's the same? No? No one thinks it's the same?
Oh, yeah.
Okay, Max is going to play devil's advocate. I mean,
Oh,
you have
you want me to
I would
explain
like you to
mine?
explain, yeah.
I was thinking of like how much the astronauts have to train because they're also experiencing the same stuff in space as the ball. So for you, it'd be just as hard to.
Okay.